To start with our second cohort of presenters, we have on stage Siyuan Mu, a Ph.D. student under the supervision of Professor Subhasis Ghoshal in Department of Civil Engineering, and she would be presenting on the cleanup of carcinogenic contaminants from groundwater. DOS is the key.
Hi. Halogenated organic contaminants, they are manufactured chemicals largely being applied in the industries. However, due to accidental spills during transportation or leakage from landfills, many of the HOCs actually end up in the subsurface environment, cause groundwater contamination. And due to their carcinogenic properties, lead to severe health concerns. Previous studies indicate that when we apply tiny nano-iron particles, we're able to achieve effective degradation of these toxic HOCs due to their increased reactive surface area. However, when we actually put the nanoparticles in the contaminated aquatic environments, we realize that water and HOC are actually competing with each other for the electrons from our nanoparticles. And due to the hydrophilic nature of our nanoparticles, more electrons tend to go to water rather than our target contaminants. And then more recent studies realized that when we incorporate sulfur in the nanoparticles, we're able to shift the electrons going to water back to our target contaminants, which is exactly what we want. But when we take a closer look, we realize that sulfidation dose plays a really important key in identifying the overall reactivity of our nanoparticles. Just like when we take medicines, dose is the key. So in our experiments, we were able to identify SNZVI of two special sulfidation dose, which either provides us a particle of high particle reactivity or a particle with enhanced hydrophobicity along with selective reactivity. And based on the actual degradation test of 4 of the representative HOCs found in groundwater, we realized that for the HOC which initially have the strong ability in getting electrons, they simply require a nanoparticle of high reactivity in giving them electrons. But on the other hand, when the HOC is too weak compared to water in getting electrons, they require the more addition of sulfur, which helps us to shift the electrons back to our target contaminants. So therefore, based on our findings, we believe that by utilizing the NZVI of optimal sulfur dose, we're able to achieve a cleaner water source, supporting our daily water usage. This is the end of my presentation. Thank you all for your attention.